Our next speaker will be talking about a little bit more down to earth, but equipment just as big. Ben Salama is Managing Director at Accenture Digital, where he leads the Industrial Internet of Things practice. He's spent the last 15 years in the mobile industry and is now working with clients in energy and utilities. That's what I meant by large equipment. Bringing the value of the Internet of Things to Accenture Digital clients. Mr. Salama is based in London. Please, Ben.
Good morning, everybody, and thank you, Richard. And I have to tell you that it's really nice to be at an event that doesn't have the word M2M in its title. I think it's about time, and we should sort of rejoice that the industry is finally moving on from that history. As Richard said, my name is Ben Salama. I'm part of Accenture Digital's IoT business. I'm the global lead for what we call our connected operations practice, which is fundamentally looking at industrial Internet of Things solutions for our clients across a number of key industrial sectors. What I'd like to do today is sort of talk through some of the issues, some of the challenges that our clients are seeing as they try to adopt IoT technologies and solutions into their business. I'd like to talk about some of what we think are the key use cases really that are defining this area, and then I'm going to close with a couple of examples that of some use cases and some case studies that we've been working with and our clients have been working with. Let me just see if I can press the correct button here. Gartner in 2014 identified IoT as the most hyped technology that they tracked, and I think that's probably no surprise if we look at all the froth that's been generated around health tracking and smartwatches and beacons for retail and wearables and so on. It's really no surprise that sort of consumer IoT has been a very, very hyped and very spoken about topic. I think the reality is that we feel certainly that consumer IoT is still very much in its infancy. I think we're all looking for what are those killer applications and those killer use cases in the consumer space that are going to have real impact for the long term. However, but when we start looking at the industrial space, I think the news is very positive. There's clearly some strong business cases. Our customers are looking at how to exploit this technology and how to start getting benefit right now from it. So we're sort of very optimistic of the opportunities that are here. I think it's also quite interesting when you look back in terms of the last 8 years. If you look at the mobile revolution, that was entirely really a consumer-driven thing, and enterprises were laggards and really had to sort of work hard to catch up and bring those benefits both into their own organizations and ultimately for their customers. And they finally made that transition and are on board with it. But if you look at IoT, I think actually we might see the opposite. We might really see that industry and enterprise is leading the way and driving out some of the short to medium-term benefits, and the consumer will come along later on. I think over the last couple of days we've seen, or you've seen, a number of studies and reports and references to such things about the opportunity that's going to be created by IoT. One of the best, I think, is this report that was produced by the World Economic Forum earlier this year. It looked at the key industries that will be impacted by the industrial internet, so manufacturing, utilities, oil and gas, mining, healthcare, and so forth, identified those industries as representing somewhere around 40% of the total output of the world, and it identified a potential benefit of in excess of $12 trillion in uplift in GDP on an annual basis within 10 years through the successful adoption of IoT. So I think there's some sort of good, strong sort of benchmarks here. I think the real question is, what do companies need to do to tap in to this opportunity, and how do they exploit it? And the answer is, unfortunately, it's not quite as straightforward as we'd all like it to be. And the fundamental reason here is that we are in an extremely complex ecosystem, and putting together IoT solutions in either the consumer space but in the industrial space is far from straightforward. Even though each of the various components might be well understood and each of the various pieces of the value chain might be well supplied, it's putting that together in an end-to-end solution that is extremely complex still today, and I think will continue to be so for some time. So if we take a look at, depending on which particular analyst's view of the number of connected devices that will be out there in 2020, whichever one you want to take, I mean, it's a big number, right? We realize that. That big number of devices turns into an even bigger number of sensors. If you look at a iPhone 6 today, I think it's got something in the range of 7 or 8 or perhaps more sensors within the device over and above the GPS and so on. So you're talking about a very large number of sensors, you're talking about a very large number of devices, you're talking about large amounts of data moving through networks, and whether these are radio networks, 4G, 3G networks, whether they're ultra-narrowband Sigfox networks or equivalents, LTE, Bluetooth, and so on. That's a lot of traffic, that's a lot of data that's moving through these network environments. It all has to flow through a series of well-structured APIs. That's really how we're going to get the leverage and how we're going to get the network effect from the Internet of Things will be through the sort of pervasive distribution of APIs in the network. And that's going to be powered, of course, by millions of applications. Many of them are going to be very, very specific. They're going to be very use case specific, very industry specific, in order to really extract the value, and then manipulating vast amounts of data. This vast amounts of data is actually sort of one of the big areas that we are spending time thinking about and looking at, because we don't actually believe that sort of big data is the answer to everything here, and there's just simply going to be too expensive to move all this data around. In the long term, there's too much of it, and it'll probably be too slow to really act on it in an effective way. So that we really have to look at the technologies that will allow us to push down to the edge, into gateways, the processing, the analytics, and the intelligence to really create a network here that has power. So a critical thing there. So you're basically looking at a pretty complex ecosystem. Of course, we're an industry in which abhors a vacuum, and as you can see from here, the marketplace has grown dramatically, and today is absolutely littered with vendors and companies that are in IoT in one form or another. So either providing various aspects, or generally providing various aspects of that value chain that I just showed you. And I think one of the biggest challenges for our customers is trying to figure out who they should be working with, what are the component parts, how do they put together the partnerships and the ecosystems that they need to put together that end-to-end value chain and start to derive some benefits. So I think we're very much in sort of the classic point of a technology cycle where there's still a lot of confusion, there's a lot of players, and the ones that are really succeeding today, and the companies, the enterprises that are getting benefit, are the ones that have been able to sort of steer their way through this complexity and confusion, and have been experimenting and coming up with some good solutions. So what is it that our customers are actually asking us for, and what are the areas that they're particularly interested in looking at? Well, I think it sort of breaks down into the three areas that you see here. The first is let's call it the classic IIoT solution area. It's help me make my assets more operationally efficient, help me save money, help me squeeze that little bit more out of my business, out of my assets, and produce operational efficiencies. I think in the future this will be table stakes, and it will really be a jumping off point for much more significant transformations that we believe we're going to see. Of course, IoT is not just about how do you save money. It's not just around operational efficiency. It's around how do you drive value, how do you drive revenue, and how do you drive growth and new businesses. And without a doubt, the single most transformational thing that we're going to see is this shift from products to services. And it's an interesting shift, because it's a transformation that is entirely enabled and exclusively enabled by IoT. So I mean, the ability to actually sell a product, the ability to actually understand how your product is being used after you've sold it across the world with every single customer in real time, that is powerful, that is transformational, and that will change the way companies market their products and provide services to their customers. it will be a very significant change. And it will be a complex change because manufacturing companies are not organized this way today. And so it will require not just a technology change, but it will require very fundamental business changes that they will need to go through in terms of how they separate their sales or how they bring together, should I say, what has historically been a manufacturing, a sales, and a service operation. If I give you a sort of a small example here, and I think there are a number, but a real-life example. One of our customers, who's an international tire manufacturer, started instrumenting their tires to look at, how do they improve the quality of their tires, how do they do a better job for their customers and build a better tire. What they realized after doing that for a while was that actually there was a much bigger opportunity here, and the opportunity was to actually stop selling tires to their customers and to start selling tires as a service to their customers. So they can charge their fleet customers on a cents per kilometer basis. And if you think about it, sort of they start changing fundamentally the engagement with their customer and the relationship they have with their customer. So first of all, their customer moves from an environment which is a sort of a capital expense to an operational expense. The customer stops worrying about testing their tires, checking the pressures, checking the wear of the tires, when do they rotate them, when do they change them. That's all being done for them by somebody else, and that somebody else replaces the tires and changes them when they need to be. So it's a fundamental shift in the way companies will sell and service and deliver their products in the future. The third area is the area that we call unconventional revenues. And this is really when you start looking at how the data that you are generating, the data that you are gathering, is deriving additional value for you in ways that you never anticipated and aren't fundamental parts of the business case that you created. So if you take the example of a car manufacturer that deploys a connected car solution, they're doing that probably, for a number of different reasons, but probably the strongest business case they've got is around, reducing warranty claims, reducing recall requirements, being able to update software in the vehicle over the air, etc. Drive the customer to a dealer and to a repair situation on an as-needed basis rather than simply on a scheduled basis. So lots of good reasons that you could create a business case around connected transportation and connected car. But interestingly enough, if you think about it, all of a sudden this car manufacturer now knows exactly where my car is, where I am at any moment in time. They know how I'm driving. They know how much fuel there is in the car. And that information all of a sudden is extremely valuable to a fuel retailer. So here we have a car manufacturer who could actually monetize its data that it's collecting for a completely different purpose, but they could monetize that data. They could make that data available to Shell, to BP, to any other fuel retailer, and that fuel retailer could then use that data to send me an offer to come in to one of their petrol stations when I'm half a kilometer away, and they know that I'm on a quarter tank. So sort of some very interesting opportunities here in terms of how you can start driving new revenue streams and new businesses completely from data that you never realized or you never sort of expected that you would be able to do that. I think it also is going to signify some very interesting changes in sort of where power sits in our internet economy. I mean, if you think about today, who are the drivers of value and who are the real value creators in the internet economy? I mean, they're the people that own and control and understand the data. It's Google, it's Amazon, it's the network effect players, it's Apple, and so on. But all of a sudden, we're going to move into an environment where large chunks of data now and valuable data are now sitting somewhere else. They're sitting with car manufacturers. They're sitting with utility companies. And so I think we're going to see some interesting shifts in terms of, or potentially interesting shifts in terms of where is that, how do you get those network effects? And in fact, these network effects might actually come not from sort of core platforms that we've seen before, like an Amazon or a Google, but perhaps they'll come from vertical applications like a connected vehicle and so forth. So those are some of the opportunities. Now, this is very much a journey, and it's a journey in which our customers are only just beginning, so I don't want to over-stress sort of the pace at which this is moving. But we really do see this as an incremental transformation that our customers will go through as a result of IIoT, starting in the left-hand corner, looking at the operational efficiency, moving through their ability to transform their selling and the manufacture of their products into services, to the outcome-based economy, and ultimately really to a view of the world in which devices and machines are interconnected and working autonomously, reducing waste and producing value. So, you think of an oil well. You're not just monitoring the performance of that drill and the components around it. You will end up in an environment where repair workers are automatically being dispatched by the well bit when the well bit realizes that an alarm's been triggered. You're looking at a situation in which the oil tanks in that oil field will be making a call on transportation tankers to come and empty them when they sense that they're getting close to completion. So we'll be looking at an economy that will be functioning much more autonomously than anything that we've seen today. Now, there's a couple of very fundamental use cases that we think power the IoT environment and the underlying value that's being created from that. So the first is the one that we call connected asset management. I think it's one that's probably fairly familiar with to all of you that are involved in IoT. But it's basically all about how do you monitor, how do you measure your assets, how do you optimize their performance, how do you move from a situation in which they break down and you have to fix them to a predictive maintenance environment and so forth. So that's a sort of a very fundamental use case within IoT. What's interesting is that if you actually look at this use case, there is huge commonality across the way you would create this use case across industries and across specific solution areas. Now, of course, the analytics and the algorithms that you'll be using will depend on the particular devices that you're monitoring. The access to the devices might change, but the underlying infrastructure and the underlying end-to-end solution that you need to build is going to be the same across these. And that's the way that within Accenture we've been working. We've been trying to create some fundamental offers and solutions that can then be customized and tailored for particular industries and to solve particular use cases. The second use case that underpins everything that we believe happens in IoT is around probably the greatest asset that you have in your enterprise, and that's the workforce. And this really comes down to how does IoT enable some new ways of the workforce operating. Now, there have been field force automation systems out in the field. We've been building them for our customers for 20 years. But what's different here is that wearable technology and IoT technology is allowing us to take a much more sort of sharp view as to how do you provide how does the worker become more effective at the point of execution of the job they're doing. So it's around how do you improve the quality of collaboration, how do you make sure that they're working in a safe and secure environment, and how do you know where they are and where are the tools that they need to do their job, and how do you bring those together in the most efficient ways. So we believe that if you take those two fundamental use cases, if you take connected asset management, if you take the connected worker, then pretty much every other use case that you're going to build in the industrial Internet of Things is some sort of industry-specific combination of those two to various degrees. And that's, as I say, the approach that we've taken by creating these sort of core underlying solutions, and we're now in the process of modifying and building those for particular customers in particular industries. And I want to give you a few examples of how we do that. So the first example here is a customer of ours that owns mining plants. What happens here is that mining plants on a regular basis, so every few years, actually need to be maintained, and the best and the most efficient way of doing that is to actually shut down the entire plant. So typically these plants are shut down. A very large contingent workforce is brought in of specialists to come in and maintain the plant. The plant shutdown can take several months. And as you can imagine, I mean, getting this wrong or overrunning costs an enormous amount of money. So every day that this turnaround and the plant stays shut can cost hundreds of millions of dollars in lost production for the owner of the plant. So getting it right is very important. What we've done here with this company is we've basically been able to do two things. We've been able to tag the workforce, the contingent workforce as they come in, because they're not necessarily familiar with the layout of the plant and where things are and so forth. And then we've also tagged key assets and key tools that they need throughout the plant. And we provide that through real-time dashboards and management systems that enables the turnaround operators and the turnaround managers to make sure that they are correctly moving people around in the correct place, that they're not involved in sort of hazardous situations, and that they've got the right tools at hand. And as a result of this, they've been able to fundamentally sort of ensure that the planned turnaround actually turns out to be the actual turnaround, and the cost they estimated turns out to be what they had expected in the first place. Okay, a very different example here, and that is a project that we've just started with Hyundai Heavy Industries, so one of the largest manufacturers of cargo ships in the world. It's a project that's going to create a connected ship solution that Hyundai will be able to sell to its operator customers when they sell them a ship. It's going to allow them to, and this is sort of actually a very typical, I think, and interesting example, because basically the data that is going to come off the thousands of sensors that are on these Hyundai manufactured ships is going to be used in two ways. Hyundai themselves, of course, will use that information in order to monitor and manage and improve the operational efficiency of the ships and the componentry within the ships that they've built. But then that information will be fed back to the operator of the ship in order for them to be able to exploit the data in all sorts of different ways. And when you start combining that data, thank you. When you start combining that data with external sources of data, so for example, what's happening in a port that the ship is sailing towards and how congested is that port, then the operator can make decisions about, well, do I slow my ship down? Do I start using less fuel? Do I incur less port fees by not arriving there by sort of arriving there later? So sort of an interesting example here of sort of this beginning of a product to service shift for Hyundai. I'd like to sort of close with a last example here, and again, I'd say this is quite typical actually of some of the use cases and some of the examples that we're seeing with our customers right now. This is a customer a U.S. customer that owns amongst others, it owns an extremely large open pit copper mine in the U.S. So we're talking about mines here that are, hundreds of square miles in size, where a pit supervisor is going to get into a truck and drive 30 minutes or more to get from one dig site to another dig site. These mines, of course, they're using very, very expensive equipment. They are digging up, 500,000 tons of ore a day. They are working sort of 2 shifts, 365 days a year, and everything is about how do they maximize the efficiency of the extraction of this ore and the processing of it. Now, what's interesting here is that actually this is not some sort of underground mine with no connectivity in some remote location. This is in the US. It's an extremely well-connected mine, and in fact, if you take a look at the sort of equipment that they have here, they have, which you can see on the left-hand side, pretty much a lot of the equipment they have is already instrumented. So, they're buying trucks from different manufacturers. Those trucks all have telematic systems in them. They all have systems in them that measure the sort of fatigue of the drivers. They have got CCTV and video cameras throughout the mine. They've got all sorts of, they're measuring the thickness of the walls, the slopes, all sorts of things. They've got views as to the quality of the ore that's in the mine itself. So you'd have thought, well, I mean, surely this is a connected mine already, but actually it's absolutely not, because what happens in this particular case is that all of this information is siloed. All of this information is being held independently by all of the systems that produce it. And actually, The way this works is that every morning or every beginning of every shift, the pit supervisor is given a thick wad of paper that contains all of the information about all of these systems at the beginning of the shift. And about 30 minutes after the shift started, this wad of paper is pretty much useless, and the information is wrong. And what we've done here is we've sort of consolidated all of this data, we've brought it together, and we've put it into a real-time dashboard that the pit supervisors are able to use. And for the first time, they've actually got real-time analysis and real-time dashboard and information that allows them to manage the pit operations. So without sort of going into the sort of details of this, but basically it's a series of dashboards that allow the pit supervisors to see what's going on. These are some sort of core and some basic pit metrics for the shift. This is an example. They actually have heat maps of the quality of the ore that's underlying in the mine as they're digging it. I don't know if you can see it, but actually there's little pictures of the actual shovels as they move in real time. And of course, one of the key things here is how do the pit supervisors make sure that the shovels are actually digging in the most lucrative and the most best places, and they can actually control this in real time. And then here, this is a dashboard which is showing basically sort of disposition of trucks, which trucks and which shovels are being used, what's happened to the drivers, why is a piece of equipment down. And all of this is now being fed into a machine learning algorithm that we're going to use to help drive some predictive maintenance around the equipment. So I just wanted to, I've sort of had my marching orders here a couple of times, so I'm going to draw this to a close. If you're interested in any of these particular cases or anything, please do come by our booth. We've got a number of these and some other, and our asset management and our worker solutions on show there. We'd be more than happy to show them to you, and I'm here today, I'm here tomorrow, and more than happy to follow up with any of you later on. Thank you very much.